now let's move on with today's lesson. All right, class, we're going to be looking at how we can use technology. So let's get straight into it. All right, Neymar, what's the description for technology?
Something man-made that help us with tasks.
Yeah, with a task, okay? Helps us to do something, achieve something. Now, Courage, does technology have to use electricity?
No.
No, it doesn't. All right, sometimes we just think that, but it doesn't. Anything that helps us with a task. So, by that logic, Ta'an, is a spoon a technology?
No,
Why?
because it's not
So, read this. Answer it
something
again.
man-made that help us with a task.
Good. Is a spoon man-made?
Yes,
Yeah. Does it help us with a task?
help us eat.
Yeah, help us eat. So that's a task. Okay, it's helping us doing something. So is a spoon a technology? Yes, it is. It fits these
I think
2
that's
points.
not a task.
Task is like objective, accomplish something. All right. So getting up in the morning is you completing a task. Brushing your teeth is you completing a task. Okay. So let me change the color of this. So class, if it's man-made and if it helps us with a task, it's technology. So Courage, am I technology? Courage, say it louder. What do you think?
Yes.
Do you think I'm technology?
Something man-made. No.
No. Okay. Am I man-made?
Yes.
Am I? Okay, let's break this down. Man-made is when someone thinks of an idea and then makes it. When a human thinks of an idea and then makes it. Okay. Yeah, so I'm not man-made. All right. So if I'm not man-made, I'm not a technology. Very simple. So animals, humans, we are natural. We are not technology. So is a spoon technology? Yes. Am I technology? No. Lily, is a motorbike technology?
Yes.
Okay, good. So is it man-made?
Yeah.
Does it help us with a task?
Yep.
Yeah, you're absolutely right. Okay, remember, technology doesn't have to be complicated. A knife, a fork, a spoon, a toothbrush, a toothpick, my glasses, anything that is man-made and helps us with a task. Okay, so Lily, how do your glasses help you?
Help me to see clearly.
Yeah, perfect. So they are a technology just by definition. Brilliant. All right, today, class, we're going to look at technologies that help us with hazards. All right, but before we do that, we need to look at this page. All right. So first of all, who's feeling sprightly today? Antung, what's wrong with this page?
What?
What is wrong with this page? Okay, I'll give you a clue. This page has a beginning, a middle, and an end. So what's wrong with it?
The number.
Kind of. Yeah, go on. Yeah.
It organized.
Nice. Unorganized. Good. The wrong order. Okay. We think about this like a timeline from beginning to end. What happens at the beginning of a tsunami? What happens at the end? Okay. So, yes, all these pictures are in the wrong order. All right. Harry Kane, please loudly and clearly read the top paragraph for this page, which is this one.
Water from a powerful tsunami can travel as far as 16 kilometers inland if the shoreline is not elevated much above sea level. A tsunami can devastate the area. Learn more about the tsunami.
Yeah, the tsunami. So, hurricane, the T in tsunami is silent. Okay, so it's kind of just tsunami. Yeah, just with an S. All right, so class, what I want us to do is identify the correct order. So have a minute just to read through this yourself. All right, so class, what I want us all to do, have a look at these pictures, have a little read in your heads, try and figure out if you can do the order in your heads. All right, don't need to write anything down yet. Yeah, so what do you think happens first? All right, so hurricane, I would like you in your head to decide which one is first and then read the text for that picture to the class.
The tsunami begins with an underwater disturbance such as an earthquake.
Brilliant. Fantastic, hurricane. Yep, fantastic. We found picture number one, class. If you got your handouts, make sure you write that number in too. Okay, Anton, it's up to you to find what happens next.
I think when the first wave reached shallow water, it slowed down. It had increased.
Yeah, its height increases. Fantastic. Good job so far, you two. Brilliant. Who am I going to move on to next? Dan, please read what you think happens next.
Tsunami, how the people and poverty by both the force of the impact and the amount of water it moves onto land.
Absolutely perfect, Dan. Yes, brilliant. Yeah, so the water goes inland, floods and destroys the environment. All right, Neymar, what do you think happens next?
After the water has drained away, many people find their homes, school, and business are destroyed.
Yeah, perfect, buddy. Perfect. All right. Yeah, so we've got that very well. So, Vin, please read the last one for me, number 5.
After a tsunami, people need to clean up and rebuild.
Yeah, I feel like you added a word there, but yeah, after a tsunami, people need to clean up and rebuild. Nicely done, class. We can easily identify the order of how a tsunami can destroy an environment. Nice. Okay, moving on. After that little warm-up, we're going to look at some technologies now, class, and we do have a bit of a mixed match game. All right, so what we have here, class, is at the top, we have the 4 water-based hazards we're studying. And at the bottom, we have descriptions on images of different technologies that help us with the different water-based hazards. All right. So by the end of doing this page, we should be able to identify which pictures match each picture at the top. But first, let's just do some reading, shall we? So we're just going to do this one at a time because there's a lot of information here. So let me pick someone. All right. So Maradona, you're going to read pink, and Harry Kane, you're going to highlight pink. Now, Maradona, before you even start, I'm going to help you with those first 4 words. Geostationary, operational, environmental satellites. It's a bit of a mouthful.
Well, I already know how to read it.
Oh, well, that's amazing then. So go for it.
Geostationary, operational, environmental satellites move so that they hover above the same place on the Earth. On Earth, information collect helps predict hurricanes and other severe weather events. They are used to warn people about hurricanes, tornadoes, and flash floods, and can help reduce the impact of a drought.
Nice, brilliant. Very good. So yeah, here we've got this big piece of machinery. All right, Lily, where does this live? So if it hovers above the earth really, really high to the point we can't see it, where is it?
It's in space.
Yeah, it's in space. Yeah, it's a satellite. Yeah, we already know what satellites are. This is just one type of satellite which helps us with predicting certain weather conditions. So, Courage. What severe weather conditions can this predict?
It can predict hurricane and several weather events.
Yeah. Okay. So it could also predict tornadoes and flash floods as well. All right. So very useful to us to try and reduce the impact or the negative effects of these weather hazards. Nice. So class, in your handouts, draw a line from this picture to the correct picture at the top of the page. Which one is it mostly used for? Which one is it mostly used for? And choose that one. Well done. All right, class, let's move it along. We're going to look back at what we studied yesterday. So, Natal, I want you to read for this. Lily, I want you to highlight for it, please.
A levee is like a wall alongside a river or other waterway to help keep flood water from slipping onto nearby land. Levees are usually made of packed dirt. Sandbags can be stacked to build walls that are similar to levees.
Perfect, fantastic. So, Natal, is a levee a technology?
Yes.
Yeah, it is. Can you explain why?
Because it is being made by humans.
Good, yeah. And does it help us perform a task?
Yes.
Yeah, it does. It helps us keep the water out. So yeah, exactly. So Natal, brilliant, fantastic. Nice. Okay, so yeah, class, we only studied that like yesterday, so we don't need to spend too much time on it. But what I would like you to do again is on your handouts, please identify the correct picture at the top of the page. Now, if you do not have a handout, class, in your notebook, you're going to use these numbers and these letters to identify and match them together. Okay, who are we going to get for the next one? Let's have a look. Ace, please be the reader for this orange square I'm about to do. C. Oh, why is that not orange? And Maradona, you can be the highlighter, please.
Deep ocean tsunamis detection buoys measure the height of the water surface. If a tsunami wave passes under a buoy, the buoy transmits the information to the tsunami warning center via satellite. The network of buoys can help scientists predict when tsunamis wave might reach shore.
Yeah, nice, Ace. Fantastic. So, Ace, this is technology.
Yes.
Can you explain why?
Because they made it. This one they made it to detect tsunamis, to warning people.
Yeah, so it performs a task, right? And is it man-made?
Yes.
Yeah, there you go. Brilliant, fantastic. Now, Courage. If the water level is high, should we be worried?
Yes.
Yeah, so it's actually both. It doesn't really say it in the text, but try and remember this. If the water level suddenly drops and goes low,
If we drought.
that's a warning. No, it can be for a tsunami as well. Okay, it just means that water is going somewhere else to power something big.
Yeah.
And if it goes too high, then that is also a warning. All right, class. So yeah, please identify the correct number with the correct letter. Match those pictures up. All right, and we're going to go to one more technology. Who's not really said anything today? It's going to help me out with the red. Neymar, yeah. All right, Neymar, can you read? Vin, can you hear me, Vin? You're going to be highlighter. Please highlight information in that red box. Neymar, go for it.
Reservoirs.
Reservoirs, yeah, good.
Reservoirs are usually constructed by building a dam on a river. Water collects in the reservoir, making it valuable during dry times. Sometimes plastic balls are put over the reservoir to prevent evaporation. They also protect the water from dust, rain, chemical, and wildlife.
Nice. Yeah, wildlife, good. Yeah, not wildfire. But yeah, Neymar, fantastic. So this is quite interesting. Neymar, why would we want to stop evaporation? If we're trying to stop evaporation, we're trying to stop the water leaving the area. So what water-based hazard are we trying to stop?
The tsunami.
Yeah, if all the water disappears, what's that?
Drought.
What is it? A drought. There we go. So we're trying to stop a drought. We're using technology, which are plastic balls, to try and prevent a drought. Okay. So,
Yes.
oh yeah, Lily.
What's the black things in the picture?
Yeah, so they are the plastic balls. Yeah, so yeah, lots of plastic balls that work by stopping evaporation. Yeah, or slowing it down. So the reservoirs will keep their water for longer, and hopefully it will stop drought. This is a new technology you will not have seen before. Okay, and it works on a couple of different ways. All right, class. So line that up, please, to the picture you think it is. I mean, to be honest, I'm going to show you all the lines now because it's pretty easy. So bees, flood, tsunami. And then the last one, as we just discussed, drought, trying to keep all of that water in one place. All right. So class, try and remember all of these technologies. We have a geostationary operational environment satellite, also known as a GOES. We also have levees, which we studied yesterday. And we have buoys, which measure how high or low the ocean is for tsunamis. And then we have black balls, which can stop or slow down the rate of evaporation. So, class, here we've got a table I want you to try and fill out for 5 minutes. All right. So listen very carefully. Identify the hazard for each technology in the first column. Okay. Then research other technologies that help us keep safe in those hazards. All right. So, class, remember what we just read. We have the technologies here. What is the hazard for each technology? And can you think of any other technologies that could help either predict or survive a natural hazard? All right, so I'm going to give you all a few minutes, actually just 2 minutes really. Try and fill out as much of this table as possible. All right, Vin, are you filling out the table? Let's go. And you see busy heads on this one. Okay, so courage, reservoirs are where we keep lots of water safe so we can use it later. So what hazard is that technology helping us with? So reservoirs where we store lots of water that we can use later.
Drought.
Thank you. Nice. Okay. Deep ocean buoys. They bounce on the ocean and tell us the height of the ocean. Harry Kane, what's the hazard?
Tsunami.
Tsunami. Lily, levees and sandbags.
It's flood.
Perfect. The really long one. All right, Tan. Geostationary operational environmental satellites.
I think that it is hurricane.
Absolutely. Thank you very much. All right, class. Now, hands. Show me your hands. Can you think of other or different technologies for any of these hazards? Any other technologies we could use? Any at all? Any for tsunamis, droughts, floods, hurricanes? No other technologies that can help us? No? I mean, for hurricane, for example, there's a weather station where we receive the information from the satellite. So weather stations technology, definitely could use that. Anyone got any other ideas? Floods, tsunamis, droughts? Come on, Maradona. You might know something. Additional technologies.
I know.
Any thoughts, Maradona?
Drought. Yeah. No.
Okay, well, water tank. A water tank is a technology. It's man-made. We use it for a task. There we go. Harry Kane, you got your hand up. What are you going to tell me?
Floodgates.
Floodgates. Nice. Brilliant. Floodgates for floods. Amazing. Come on, class. We need to think is that another technology we can use for tsunami.
Can we use seismograph?
Oh, Lily, I was waiting for someone to say that. Yes, if we know there's an earthquake coming in the ocean, we know there's a good chance of a tsunami. Lily, you should be dancing. Well done. Brilliant. Look at that, class. Yeah, Lily, very impressive. Good job. Harry Kane, very good with the water floodgates. Fantastic. I think, class, that's more or less going to wrap us up to the end of the lesson. So what I'll do is I'll explain the homework. If we've got a bit of time left, we'll discuss some stuff. All right, class, the homework is pretty simple today. All right. Seeing as we've just done a little bit on reservoirs, I want you to answer questions 21 and 22 in the textbook, page 607. Simple homework. All right. Now we've got 3 minutes left. All right. Class, we've got 3 minutes left. Let's do one drawing. Listen to me very carefully. Class, please draw for me a technology we can use to predict hurricanes. Go. Annotate should be on. Yeah, it is. Yeah, brilliant. So everyone make a start. You've got about a minute to see what drawings you can come up with to predict hurricanes. What's it going to look like? Where does it live? I'm going to draw one too. Why not? Oh, light blue drawer's got the right idea. Ace, yeah, that's right. I was actually going to do the same thing. All right, so yeah, draw the planet here. Do some squiggly bits. Ace, you're copying my idea.
I didn't copy you. Copy
I'm
my
joking,
idea.
Ace. I'm joking. Great minds think alike. It's good. Okay. Okay, Harry Kane. Yeah, I see it now. Yeah, weather station. That's good too. That's good too. Yeah, so it could be weather station or satellite. Two main things we use to try and predict hurricanes. Brilliant stuff. But class, sorry if you took a bit longer than expected because that is the end of the lesson. So I'm going to stop it there. All right, but not bad for the people who finished it. Very sore throat today. All right, class, remember your homework. Questions 21, questions 22, page 609, I think it was. 607, sorry. All right. Try and remember the different technologies because we're going to recap it tomorrow before we do all our reviews for the rest of the week. So,
I finished our homework.
nice. All right, class, thank you very much for a great lesson. I'm going to see you all tomorrow morning where we'll see Courage do 10 more jumping jacks.
Amazing, good job.
If you're sleeping in my class, jumping jacks, that's the rule. All right, class. Goodbye, everybody.
You might be drop most.